Okay, so this video is going to go over pages 15 through 17. We're actually going to talk about calculating speed and velocity. So we're going to look at speed first. That is going to be your distance traveled per unit of time. Okay, it is a scalar quantity, so you need to make sure you remember that term. Okay, scalar means it has no direction. Okay, so that'd be like me saying, an example would be like 28 meters per second. That would be scalar because there's no direction involved. It's not telling me where it's going, it's just telling me a number. So distance and speed are both scalar quantities. Distance doesn't care about which direction you go. You're just basically adding it all up. Therefore, speed doesn't care either. It is always positive, okay? There is no negative because think of it like mileage on your car. There is no negative mileage. You're just adding it up. Your formula for speed is going to be S, or speed equals distance over time. Okay, so distance is just that lowercase d without the triangle. Okay, so we're going to show you a little trick on this. Is if you get kind of hung up on how to manipulate an equation, okay, you can use this circle trick, okay, where you're going to draw a circle and S equals d over t. So what this does is if you were to take your finger and cover up what you're looking for, so say I wanted to know speed. I would put my thumb over the S, and that would mean I would take distance divided by time. If I was looking for time, I would cover it up. That would be distance divided by speed. And if I was looking for distance, I would cover that up, and that would be speed times time. Okay, so that's a little trick, but the only thing about that is you just got to make sure you know how to write that. Okay, so I've seen some that are trying to do that circle, but then you've got your letters in the wrong place. So just be careful with that. And our unit for speed, our SI unit, is going to be meters per second. So nothing new there. Now velocity is displacement per unit of time. So displacement, remember that term, that just meant where you ended versus where you started. Okay, now that is a vector quantity. So vector meaning you have direction. Okay, so displacement does care about where you ended versus where you started, so direction does matter. Okay, so that's why it's vector. In velocity, since velocity uses displacement, velocity has to be a vector as well. And it can be positive or negative because you can have a positive direction or negative direction. And our formula for velocity is going to look a lot like speed. Okay, it's going to be velocity equals displacement over time. So I can use that same kind of little trick with the circle, and velocity equals displacement over time. Okay, so now ultimately, does it really matter which equation you used? Would it matter if you thought it was speed versus velocity? No, because you're basically still doing the same thing. You're still taking distance or displacement and dividing it by time. So that's not really huge if you use the wrong equation because it's basically the same thing. And our velocity unit is going to be, our SI unit is meters per second. So that's our answer for the next one, is meters per second. Now, if you want to, so say I gave you kilometers per hour, and I want it in meters per second. Okay, what you're going to do is you're going to divide that by 3.6. Okay, versus the opposite is, say, is if you were meters per second and I wanted you to go to kilometers per hour, I would multiply by 3.6. That is just a constant value. Okay, so the way I remember that is when to divide, when to multiply is if I'm going from an hour to a second, that should get smaller. Okay, so there's a lot of seconds in an hour. If I'm just going to 1 second, that number should get smaller, so that means I'm going to divide by 3.6. Now, a car at a position at C at 3 p.m. Okay, so what I'm going to do is I'm going to draw this little number line for an example. So at point C, it's going to be 3 p.m. And that we're going to say that is 60 kilometers. Okay, and it's at a position A at 4:30 p.m. So we're going to say this is position A. That is going to be 4:30 p.m. And that is going to be at negative 80 kilometers. And we're just going to throw a B in there just to show where zero's at. Oops, let me go back on that. So B's right there. So that is going to be a 0 kilometer. Just kind of show you the middle. So A says, what is my displacement? Okay, displacement is just where did you end versus where did you start. So if you want to remember that equation, displacement is your final position minus your initial position. So you just got to be careful with this number line. Our instinct is to say that C is our final position, but if you look at time-wise, okay, 4:30 p.m. would be my final position. So that's going to be negative 80 minus my initial position, which is going to be 60 kilometers. So negative 80 minus 60 is going to give me negative 140 kilometers. So there's your answer for A. B says calculate velocity. So velocity I don't know, so there's my question mark. Okay, I know displacement now. I just found that was negative 140 kilometers. And my time, if you look at my time, I started at 3 p.m. and I ended at 4:30 p.m. So that would be 1.5 hours. So if I want to calculate velocity, so velocity equals displacement over time. So it's going to be negative 140 divided by 1.5. Okay, so put that in the calculator and you should get negative 93.3 kilometers per hour. And that would be your answer for B. Now part C, it says, I want it expressed in SI units. What that means is we need to do it in meters per second. So what's important is don't always feel like you have to convert it to meters per second. Okay, it's basically only if we ask you to. So what I'm going to do is in part C, I'm going to take that negative 93.3 and I'm going 2 meters per second. So I'm going to divide by 3.6 and I'm going to get negative 25.9 meters per second. And there's your answer for C. Moving on, I gave you these little tricks up here so you can use those if you want to. Okay, number one, what is the uniform velocity, that means not changing, of an airplane that flies 602 meters east in 2.50 seconds? Now what I like to do is I like to label out what I'm given and what I'm looking for. So it says, what is velocity? So that is my question mark. Okay, flies 602 meters east. So that's definitely not my velocity. It's definitely not my time. So that would have to be my displacement. So I'm going to put 602 meters. And if I tell you east, that's probably for a reason. So I'm going to keep that east right there. And my time would be 2.50 seconds. Okay, so I'm going to use my equation. Velocity equals displacement over time. So V I don't know. My displacement is 602. And my time would be 2.50 seconds. So if you were to type in the calculator, what you're going to get is going to be 240.8 meters per second. And I'm going to do is I'm not done yet, because if we're talking about velocity here, usually that's going to be a vector quantity, which means there's a direction. If I told you it was east in the beginning, okay, you would need to keep that east in the answer. So that would be my answer right there. Now it says express your answer in meters per second and in kilometers per hour. So we're going to change that to kilometers per hour. So I'm going to take that 240.8. I'm going to multiply it by 3.6 this time. And that's going to give me 866.88 kilometers per hour. Kind of ran out of room. And I'm going to keep that east right there. So that would be your answer for that. So just don't forget to add that direction. If it's in the problem, usually it's a reason in the problem. If it's not there, don't worry about it. 2, the ends of a tuning fork move 1.0 millimeters. Okay, so that is going to be my distance or displacement. But we don't like that millimeters. Okay, so remember there's 1,000 millimeters in 1 meter. So I'm going to go ahead and I'm going to divide that by 1,000. That's going to give me 0.001 meters. Now my time, it said 4.0 times 10 to the negative 3 seconds. So 4.0 times 10 to the negative 3 seconds. Now you can keep it like that if you want to. If you do, I highly recommend that whenever you put it in the calculator, just put that whole thing in parentheses. Okay, that way your calculator doesn't mess up its order of function. Or you can convert it back to a normal number, a standard number. So the key there is look at your exponent. A negative 3 means that's a small number. So if you want this to become a small number, my decimal has to move to the left 3 times. 1, 2, 3. And then you just fill in the blanks with zeros. So that's the same thing as saying 0.004 seconds. Now, I'm looking for velocity. I don't know what it is. I'm looking for it in meters per second, so that's my question mark. So velocity equals my displacement, 0.001, over my time, 0.004. And that's going to equal 0.25 meters per second. And we did not mention direction at all, so don't have to worry about adding anything there. Number 3, an electron travels at a constant velocity of 1.30 times 10 to the 5th meters per second. So that is my velocity. I'm gonna go ahead and keep it in that form. You can convert it if you want to. So just watch out for that positive exponent. That means that's a big number, so you'd move that decimal to the right 5 times, which would be the same thing as saying 130,000. So how much time is needed? Okay, so time is your question mark. For it to travel 1.00 meters. Okay, so my displacement is going to be 1.00 meters. So 2 ways you can look at this is if you look at the equation, velocity equals displacement over time. If I were to plug this in, 1.30 times 10 to the 5th is my velocity equals my displacement, which is 1.00 over time. I don't know. I'm going to keep it as t. Now, the number one algebra mistake we see is we see students try to multiply both sides by 1 to get rid of it off that t. Now, you could do that if 1 was on bottom, but in this case, it's on top. You can't do that. So there's 2 ways you can look at this. One, you can look at this trick. Is anytime you're looking for a variable on bottom, you can just switch those two, or just go back up to your circle on the top. If I'm looking for t, I would cover up t. That means it's displacement divided by velocity. Okay, so either way, whatever works for you, you can use a switch trick, or you can use that nice little circle model up at the top. So regardless, it's going to be 1 divided by 1.30 times 10 to the 5th. Okay, so when we put in that calculator, we're going to get 7.69 times 10 to the negative 6 seconds. Okay, number 4, a spaceship traveled at a uniform velocity of 3.2 times 10 to the 4th kilometers per hour. So velocity 3.2 times 10 to the 4th kilometers per hour. For 2.7 days, that is going to be my time. That's definitely not my displacement. What was the displacement in meters? Okay, key thing there is meters, so displacement, I don't know. So this is going to be kind of a lot of conversions, and you're not going to see a ton of this, but we will see some of this stuff later on. So if I want it in meters, what I'm going to go ahead and do is I'm going to divide this velocity by 3.6 just to get it to meters per second. So I'm just going to go ahead and do that step. That gives me 8,888.89, a lot of 8s, meters per second. Okay, so that fixes that velocity there. For time, it doesn't do me any good to have days when I want something in my velocities in seconds. So I'm going to convert that. So 2.7 days, I'm going to multiply that by 24 hours since there's 24 hours in a day. Okay, and then I'm going to multiply that by 60 minutes because there's 60 minutes in an hour. And then I'm going to multiply it by 60 seconds because there's 60 seconds in 1 minute. So that comes out to be 233,280 seconds. And again, you're not normally going to deal with a lot of huge numbers like this, but it does happen, especially when we start talking about things in space, because they do cover things very quickly. Okay, you have a high velocity and high displacement. So I know my velocity now. So that's going to be 8,888.89 equals displacement. I don't know. And my time is going to be 233.280 seconds. I'm sorry, 233,280 seconds. So if I multiply both sides, you're going to get a really big number. I'm just going to keep it in scientific notation. If you want to keep it normal, you totally can. I got a displacement of 2.07 times 10 to the 9th meters. Now again, that was a lot of big numbers and conversions and stuff, so a lot of your problems are not going to look like that, but this is just good practice on doing some simple conversions to meters per second and converting some time. Okay, so number 5, we're going to take a break from calculations for a sec. A car and a truck travel along the same highway with a car moving faster than the truck. So naturally, the car is going to go faster. How do their distances traveled compare after the same length of time? So basically what that's stating is, if I gave them both 10 seconds to get as far as they could, how do their distances compare? Okay, well naturally, the car is going to have further displacement. So it's going to have further displacement because it has that higher velocity. So this is just some conceptual questions when you're thinking about velocity equals displacement over time. And then B, how do their times compare after traveling the same distance? So let's say we did the quarter-mile race, and I want to know what do their times look like compared to each other. Okay, so the car is going to have, oops, let me go back on that. Car will have a shorter time. Sorry, I can't write right now. So if the car is able to move faster and has a higher velocity, it's going to cover that distance in shorter time than the truck would. Okay, so that's just kind of navigating conceptually around the equation. Number 6, the cruise control of a car is set at 90 kilometers per hour. Okay, so if you're the type where word problems just kind of jumble in your head and you're like, I don't know what's going on, start with this step where you just label out what you have and what you're looking for. Okay, so I just said that my velocity is 90 kilometers per hour. What distance in kilometers, okay, so that means distance I do not know, so that's your question mark, is traveled by the car in 2.5 hours, so there's your time. Okay, so I'm going to use my equation, velocity equals displacement over time, so 90 equals displacement or distance in this case. Doesn't matter, so again, don't get too hung up on this, basically the same equation. And my time is 2.5 hours. Now what you can do is you can multiply both sides by 2.5. Okay, so to get that 2.5 off bottom, just multiply both sides. So 90 times 2.5 is going to give me 225 kilometers. And there is your answer right there. 7, this is mostly to show you how we got that 3.6 number. So if I have 1 meter per second, okay, so if I'm going to kilometers per hour, we know that 1,000 meters equals 1 kilometer. Okay, so that converts that. And then if I was looking at seconds, okay, there are 3,600 seconds in 1 hour. Okay, so that would be just a dimensional analysis conversion. So that's just showing you where the 3.6 came from. Because if you take 3,600 and divide it by 1,000, you're going to get 3.6. Okay, so that's where we get that conversion number from. Don't really have to worry about trying to reproduce that. That's just showing you how we got it. 8, use the conversion factor in question 7 to convert. So I'm going from kilometers per hour to meters per second. So I'm going to take that 92 and divide it by 3.6. Remember, you're going from hours to seconds, so it should get smaller. Okay, so I got 25.56 meters per second. And if you ever get a really long decimal number in your calculator, just use 2 decimal places. That's totally fine. B, I'm going to go from 21 meters per second into kilometers per hour, so I'm going 2 kilometers per hour. So I'm going to take that 21 and multiply it by 3.6. That's going to give me 75.6 kilometers per hour. Okay, last problem on this video. In 1997, Thrust SSC, the world's fastest jet engine car, traveled 604 meters. Okay, so again, if we're looking for velocity, displacement, and time, okay, you got to figure out what that just told me. 604 meters would be our displacement, or distance, doesn't matter in this case. At an average speed of 341 meters per second, so 341 meters per second. Now, if you did S, D, T, that's totally fine. Okay, when it comes to this, when we're not really talking about direction, you could use either one. It's not really a big deal. And then time, I want to know how much time did it take. So there's your question mark. So I'm going to use my equation, velocity 341 equals displacement 604 over time. So I'm going to use that switch trick because I got T on bottom. So it's going to be 604 divided by 341. And that would be 1.77 seconds. Now, if you ever get a really big number and you're like, I don't know if that's right, just try to look at the question and think of it conceptually. If I have a car that can go 341 meters per second, and I want to know how long it takes to go 604 meters, it should not take very long at all, okay, versus, let's just say you multiply the 341 times 604. Would it make sense to have that many seconds to travel just 604 meters? No, it would not. So just kind of think about that sometimes if you're ever worried about the number being too big or too small. B, then convert the 341 meters per second into kilometers per hour. So I'm going to take that 341. I'm going 2 kilometers per hour, so I'm going to multiply it by 3.6. And I get 1,227.6 kilometers per hour. And there's your answer, and that's the end of that video.